Hi everyone, welcome back. Hope those readings and those videos made sense for you. I like that video by Barbara Patelli where she's hiking through the woods, and when I was watching that video, I was just like, oh, I wish I was there right now. But I'm not there, I'm here, and it's time to do takeaways from this week. So, a lot of articles about depth of field and aperture, so we're just going to talk a little bit about aperture in the next couple minutes. So today I'm going to introduce you to some photography jargon. And I don't know if you know what jargon, the word jargon means, but it typically refers to specialized language or specific terminology that is used only in an industry. So in photography, there are some words and some phrases and expressions that we'll use that really only make sense to people who are in photography. So to introduce the first jargon, and there's a bunch of them I'll talk about this semester, I got a question for you. What is the maximum aperture of your lens? So what is the biggest opening you can produce on your lens? So some of you might have a lens that opens up to a maximum aperture of, let's say, 3.5. Some of you will have a lens that opens up to 2.8. So everyone's lens is a little bit different. So what is the maximum aperture of your lens? Well, typically when someone asks that question, what they'll say is, how fast is your lens? How fast is your lens? Well, what they're asking you is, what's the maximum aperture of your lens? So how fast is your lens is something that you'll hear people talk about. So I don't want to get too deep into this because that's something you should do in your practical class. But how do you know how fast your lens is? Well, it's usually stamped on the side of your lens, or it might be on the inside ring, where it will show you what the maximum aperture of your lens is. And so if you want to know how fast your lens is, that's where you would check. You might also hear people say, this lens is a slow lens, which means it doesn't open up to a very big aperture. So as an example, let me use that in a sentence. Someone might say, hey, I bought this lens at a garage sale. It only cost me 10 bucks. It's not a great lens. In fact, it's a slow lens. Well, when they say it's a slow lens, it means it doesn't open up to a very large aperture. And usually lenses that don't open up to large apertures, they're kind of cheap and they're inexpensive. That's why it's stamped on the lens. It's a very important piece of information people like to know about a lens, is how big of an aperture it can produce. Anyways, there's an example there. There's a lens that opens up to 1.8, and that lens opens up to 2.8. So we would say that this is a faster lens. So just make sure you know that for the test, because there's a question about that. I'm going to give you two lenses, and I want you to tell me which one's the faster lens. You might also notice that some lenses, especially zoom lenses, the maximum aperture actually changes. So this lens shows a range, 3.5 to f5.6. So that's because when it's wide angle, when it's zoomed out to 18 millimeter, it has a maximum aperture of 3.5. But when you zoom into 55 millimeter, the maximum aperture that it can produce is f5.6. Anyways, there you go. Just giving you examples of where you would see some photography jargon when people talk about fast lenses and slow lenses. And just for fun, I put this picture of this camera up here, and this lens has a maximum aperture of f.95. What I'd like you to do just for fun is Google that lens and see if you can figure out how much that lens cost, and maybe send me an email or put it on the message board. I'd like to see what different prices people are finding for that lens. Kind of a strange, unusual lens. So that was my lead-in to talk about aperture. So now we're just going to take a closer look at aperture. A lot of people, not a lot of people, but some people ask me, why are the apertures such strange numbers? Why is it f8? Why is it f11? Where do those numbers come from? So we're going to look at that. F numbers, known as f-stops, okay, are defined as the ratio of a focal length to the lens diameter. So a couple of concepts that maybe we should talk about, and I'm just going to jump through this. We're going to pass this form. I'm just going to jump to this part. I've got a diagram here of two lenses. One's a 50 millimeter lens, one's a 28 millimeter lens. Both of them are showing f8. This distance here, what this is showing us is, imagine if you were to turn that lens sideways, and the sensor would be over here, and this is a 50 millimeter lens, so that means that this distance from here to here is 50 millimeters. That's where this focal length number comes from, 50 millimeter. So when this is f8, that is a specific diameter. We could actually measure that with a ruler if we wanted to. And when we talk about f8, let me just back up over here. The ratio of the focal length of the lens diameter. So what that means is, how many times does that fit into that? The ratio of this size compared to that length. So if you were to take this and measure it, you would see that within that distance from the lens to the sensor, that distance fits 8 times. That diameter fits inside that focal length 8 times. I just want to make sure we're understanding this concept of focal length. So if this was this lens, a 50 millimeter lens, then the distance from here to where our sensor is at the back, that would be 50 millimeters. So how many times does that diameter fit inside that lens? Same thing down here. This hole's a smaller. We're going to explain why it's smaller in just a moment. But same thing. A focal length on this lens is shorter, and that hole fits in that length 8 times. So that's why this lens we call that f8. So that's where that number comes from. If we were to make this lens f11, the hole would be smaller. And that hole, or that diameter, would fit within that distance 11 times. So that would be f11. That's where that comes from. So now that we understand this concept, now I'm going to go back to, this is the slide that I skipped over earlier. And there's a formula there, F number equals F over D, so F is obviously our aperture number, but F is our focal length, measured in millimeters, divided by the actual diameter of our aperture. If we were to get out the ruler and actually measure it, and see what it is in millimeters, how many times does that fit within our focal length? So sometimes I think it's better to look at this than to look at a formula sometimes. So here's another concept I just want to show you. Again, part of my lesson today is based on questions that I've received from some students. So one student noticed that, hey, when I start comparing lenses, f8 is not the same size on both lenses. f11 is not the same size on 2 different lenses. So I'm just going to show you an example here. I've got 2 lenses, and if I set them both so I'm just adjusting the aperture there, and I'm setting them both to f8. And when I look at them, they are 2 completely different sizes. I don't know if you guys can see that, but both of these lenses are set to f8, and they're completely different sizes. So what that's illustrating for us is that f8 is not an absolute size. It's not like if I were to measure one of the ceiling tiles that are above my head here. Each one of them is 2 feet by 4 feet. Well, no matter where I go in the world, 2 feet by 4 feet is the same size. A centimeter here is a centimeter anywhere else. It's a fixed size. A meter is a fixed size. f8 is not a fixed size. It's a ratio, like we just looked at earlier. So F8 isn't a specific size. You couldn't go to a donut shop and say, hey, I want a donut that's about F1.8, because F1.8 could be different sizes depending on which lens you have. So there's a thing called, a concept called the universality of apertures between camera formats and lens. And what they're talking about is F8 always passes the same volume of light to the sensor. So while F8 might be a different size in different lenses, like physical size, one thing that is universal is if I set this lens to F8 and I were to measure the amount of light hitting the sensor and record that, for example, and I take this lens that has a much larger opening for F8. So even though this has a larger opening, when I go to the sensor and measure how much light is hitting the sensor, it's the same. So regardless the actual physical size of the hole, F8 is F8 on any lens, and the amount of light getting through will be the same for all those lenses. So why is that? Well, probably the best way to explain that is just sort of look at these diagrams. So F8 always passes the same volume of light. How can that be? These are two different size holes. You and I intuitively can figure out that, hey, if a hole is bigger, more light's getting through. True. However, this is a larger hole, but that light, if you remember what we said about focal length, the distance from the lens to the sensor, that light has a longer distance to travel. On a 28mm lens, the distance that the light has to travel to hit the sensor is much shorter. So the hole can be smaller. In fact, it needs to be smaller for those exposures to be consistent. So that's why when you look at one lens and compare it to another, the actual aperture size might not be the same, even though they're both at the same f-stop. I'm going to skip this slide because we talked about that last week. And now we're going to talk about depth of field.